Hello everyone, developers. Today, I'm bringing you the topic of applications based on RTRI's BI Kit Image Disconnect. This share will last about 30 minutes, and I will cover the following 6 parts. First, there is an introduction to the Kit protocol. Then came the introduction of the COE protocol. Then came the introduction of the CIF402 agreement. Next is the advantage of AR's real-time operating system in EtherCAT. Then there is an introduction to the SSC protocol station migration. The last one is the demo of Peter K's main battle. First, let's take a look at the agreement between E and K. In industrial automation, precise synchronization between devices is often required, such as when robots work together. Traditional Ethernet has high latency and uncertainty, unable to meet the demands of these high real-time scenarios. Liu Zhibing's agreement was born to solve this problem. It optimized the traditional communication method of the tire mesh and adopted a main gravity communication architecture. Send one frame of data periodically through the main battle. All are connected in series, receiving and processing, achieving microsecond synchronization. A faction agreement station. The design is layered, with the physical layer responsible for signal transmission. The structure of the data link layer processing frame. Application layer to achieve specific communication. The data frame sent by the main station can contain multiple subpackets. After each segment reads or writes its own part. Continued transmission. This mechanism of receiving and processing simultaneously greatly improves communication efficiency. Meanwhile, EtherCAT supports broadcast, unicast, and other communication methods, meeting data exchange needs between different devices. It can flexibly adapt to complex industrial scenarios. Next, some physical properties. In terms of the physical layer, the nodes are always open between them. Minimum. Up to 100 meters. Meets the wiring needs of factory workshops in terms of topology structure. Supports linear, vertical, heart-shaped, even redundant loops. Exist with 1 to 4 ports. Multi-port devices can serve as branches or hubs. Adapts to complex industrial site layouts, theoretically supporting up to 65,535 nodes. Unified support. Automatic port detection. The last one has an automatic closed port. Returns the data frame to the main station. No need for additional switches, greatly simplifying the network architecture. Supports frames, compared to traditional Ethernet stations. United Front receives and processes data simultaneously, reading and writing data in real time, improving the utilization rate of the bus. Common open source main battle SO, open source United Front SOS. SSC, etc. provide developers with low-cost deployment memory battle solutions. Promote the popularization of EtherCAT technology. Additionally, 1K has the following advantages. 1K distributed clock can synchronize each existence time to sub-microsecond level. The jitter during wave axis synchronization control is extremely small, ensuring high-precision motion control. In the network, each cycle only needs to send one frame of data. All I/O data updates simultaneously, no need to send/receive individually for each device, significantly reducing communication overhead and improving real-time performance. At the same time, the data carrying capacity of one network frame is very strong. The main battle does not need to create a new data frame for each United Front. All United Front members share one network frame for data exchange, which is highly reliable and supports network redundancy. You see, Kit has a mature ecosystem, including support for open-source protocols such as SSC. It supports multiple protocols, such as CANopen, etc. The full name of CAN is CANopen over EtherCAT. It is running the CANopen protocol on the 1K protocol. The full name of SO is So, drive over EtherCAT is usually used to control 4-voltage motors. The full name of UE is over CAT. This protocol allows 1KIT to segment transmit standard Ethernet data packets, making the 1KIT protocol also support TCP and UDP protocols. FOE stands for FireRail, War as a Cat. This protocol allows a CAT bus for uploading, downloading, or updating firmware for storage devices. Then is the CEO introduction. KIT supports multiple protocols, with CoE being the most commonly used. CoE supports various devices and applications, serving as an essential component of a CAT network. Expanding the application scope of K, CoE runs the CANopen protocol on an EtherCAT bus. This combination preserves the CANopen object dictionary model and inherits the high bandwidth and real-time capabilities of EtherCAT. CO allows open devices to seamlessly connect to a CAT network, achieving device interoperability and simplifying system integration. It also reduces development costs and improves system performance. It is an important technology in industrial automation. SDO is typically used for device configuration and diagnostics. Main station sends a single command. Substation returns specific data. Using SDO for object dictionary access and configuration allows flexible parameter configuration. PDO transmits small batches of data with high real-time requirements. Main station issues a PTO command. Unified station responds promptly, transmitting motor position, speed, etc., control data in real time. PDO communication requires mapping configuration to ensure accurate data transmission, guaranteeing system real-time performance. The communication process of CoE includes initialization, pre-operation, safe operation. Operation phases. Each phase has corresponding state transitions. Ensure communication stability. As shown in the figure, the master station periodically sends data frames. All slave stations in series receive and process them. The data frames sent by the master station can contain multiple subpackets. Each slave station reads or writes its own part and continues transmission. This mechanism of receiving and processing simultaneously greatly improves communication efficiency. Next is a CAT state machine. A CAT device needs to support 4 states. You need pre-operational set, operation, and operational states. The master station and unified station coordinate state transitions to the state machine to ensure consistency. After entering the pre-operation state, SDO communication can be performed. After entering the operation state, periodic PU data center operations can be performed. Then is an introduction to the CIA 402 protocol. When discussing industrial 4-axis control, we must mention the CIA 402 protocol, which is a standard driver device protocol. CIA 402 was initially based on CANopen protocol, inheriting its communication architecture and some functions. With the development of industrial Ethernet, the CIA 402 protocol was expanded by the CAT CoE technology to cover a wider range of applications. CIA 402 protocol defines the status of devices such as motors and drivers, standardizes device operation status transitions, and specifies control words, status words, etc. in the object dictionary. Achieve efficient control and feedback between devices. CA402 protocol, compatible with multiple industrial reconstructions, such as CANopen as CAT, adapts to different industrial scenarios, supports various operation modes, can be flexibly extended to meet complex control needs. The object dictionary structure is divided into communication areas: factory, business area, and configuration area. ES file is a description file for opening equipment based on XMLR file. The main station can parse the object dictionary, PU mapping, synchronization management configuration, etc. through FE file. The main station automatically reads the ES file upon startup, identifies the model and functions of the substation, and completes the network topology. Ensures equipment compatibility and communication stability. EtherCAT system uses the object dictionary as a standard communication interface. Different control parameters are accessed through indexed addresses. The following tables are common core object entries in the CA402 standard. Used to implement 4-fiber control-related functions. Control class objects determine the state transitions of the substation equipment and work with the state machine. Setting operation mode objects can set the electrical control mode. For example, CP mode, CV mode, CST mode, etc. Target and feedback class objects are used to transmit motion control target commands and actual data between the main station and the substation. Feedback. After PD mapping, efficient real-time communication can be achieved. The diagram shows the standard state machine flow. From power on to entering operation mode, multiple state transitions must occur sequentially, each requiring a control step. The main states of the 3A402 state machine include not ready to switch on,
not ready to on, switch on operation in neighbor, quick stop, active activity.
Each state has a clear control word and state transition mechanism. Ensure the driver operates safely and reliably. The core of the 3A402 state machine is state machine control and operation mode definition. Each continuously operating storage device, such as a servo motor. After power on, they all require initialization. Unready, ready, power on operation room, etc. are several key states. Only then can the device officially receive movement commands. Initialization configuration includes device parameter settings, communication protocol configuration, etc., ensuring normal operation of the device. Entering the dead state requires meeting specific conditions. For example, the device status is normal, control is correct, etc. The enable state is a prerequisite for device operation, ensuring safe operation. The operation modes of the character motor include synchronous position mode, synchronous speed mode, synchronous torque mode, etc. The main station sends the target value, the unified station responds, and controls the device's movement. Next is an introduction to RTRE, which is an open-source embedded real-time operating system. Born in 2006, after years of development, it now has a powerful core and ecosystem. Widely applied in industrial, IoT, and other scenarios. Its features include strong real-time performance. Using a priority occupation scheduling algorithm, it is suitable for industrial applications that are sensitive to food inspection. Adopts modular design, allows component trimming, and adapts to different resource levels of MC. Low resource consumption, small core size, suitable for low-power devices. Supports multiple architectures like ARM, CAR M series, etc. Riscofi series, etc. For AK application, RTSRs. Provides multitasking scheduling. Can reasonably allocate CPU resources, ensuring the communication tasks of an IGK's real-time performance. Meanwhile, the network protocol of ASRE simplifies the K protocol's porting and integration. Accelerates development process. The combination of a DIS2 and SSC protocol can achieve lightweight, real-time, efficient unified solutions. Why does a cheese use priority-based preemptive scheduling? High-priority threads can preempt low-priority ones. Setting K's unified tasks to high priority ensures real-time performance. Ensures timely data processing response. To meet the strict continuous requirements of power control, multi-threaded scheduling sets the communication thread of K to high priority, ensuring real-time processing. Meanwhile, R has independent interrupt stations and nested interrupt mechanisms, allowing timely response and true reception of events. IR also provides a timer interface and delay functions, supporting periodic task scheduling. Next is the porting of the SSC protocol. The full name of SSC is Smell Sky. The code was proposed by Backoff Company, and it is a protocol station specifically designed for the EtherCAT heavy war. Written in pure C language, it has good portability. The SSC protocol supports standards such as SOEE and FOE. United Front Functions. These functions meet the needs of industrial automation. The diverse needs for communication and collaborative work between devices. Using the SCTO tool, you can generate object dictionaries and descriptor files. Simplified the development process. The SRSC protocol station meets the basic needs of E-inflation and can achieve efficient data transmission. For example, P can quickly transmit real-time data. SDO is used for configuring device parameters, enhancing communication flexibility. The SSC collaboration station supports distributed clocks. Distributed clocks can ensure high time synchronization accuracy between devices, making them suitable for high-precision motion control mirroring. For example, in multi-axis synchronous motion control, a distributed clock can precisely coordinate the movements of all axes with minimal error. The image shows the file structure related to the existence of CO, including core protocols, processing some documents, files related to the application layer, files supported by data and services, and some files with the same definition. The last part is a demo of a one-color kite group's combat. Please click the switch to connect simultaneously. Then, click the slider to set the motor's target position. Then, the motor rotates to the corresponding target position. Next, switch to CSV mode. The speed is 2. Clicking the overseas can set the target speed. The motor can quickly update its status. Click the switch again to stop the electric shock. Based on RTS's external one-load station development, it combines the flexibility of open-source RTOS with the high performance of industrial protocols. Suitable for high-performance, high-implementation requirement control systems. Thank you all for watching.